Alrighty, third grade, this is chapter 20, extra practice on page 418. You do need a sheet of paper. I have everything filled out. I have my name, I have my date, and I have what assignment I'm working on. So this is getting us ready for our open book chapter 20 test. And what I'm going to do is I'm going to do 1 through 7 with you, but then I am actually going to show you where you can look back in the book for the answers. So for number 1, 2, and 3, it's asking us, tell if the blue line is a line of symmetry, right? Yes or no. So line of symmetry, going back to page 410, is if it can be folded along a line so that the two parts match exactly. And that line is called the line of symmetry. So you can see with this shape, there is one line of symmetry. This rectangle has two, it folded two different ways. This triangle actually has three, and this shape has 0. So going back in here, number 1, if I folded along this blue line, would they match exactly? And for number 1, they would. So for number 1, I'm going to put yes. Okay, let's look at number 2. It kind of looks like a rectangle pushed over, right? But if I fold that, it's not a mirror, right? This goes kind of in to the right and this goes out to the left. So number 2 is no. And then number 3 kind of looks like the end of an arrow, right? Are they identical? If I fold along that blue line, will they match exactly? And I'm thinking they are. So number 3 is yes. So that's the line of symmetry. Now, number 4, 5, and 6, you actually have to trace the shapes and then draw the lines of symmetry. Now, I can't really trace on my computer like you should with your piece of paper. You're going to put your piece of paper over your book to trace the figure. I am going to act like I did, but I'm going to drag the shape over just like I would have done if I would have had the sheet of paper in front of me over top of my book. So this is number 4. Okay, so where can I draw a line of symmetry that when I fold it, it's going to be matching exactly? And right now, I'm only seeing 1, and that is going to be when it goes up and down. I know it's blue, so I'm actually going to change that color so it kind of stands out to you. To green. So you can see it right there, goes right down the middle. Okay, 1 line of symmetry. Okay, then I bring my sheet of paper back on top of my book. I'm going to trace this triangle. But my tracing means I'm going to bring it over. Okay, now can I take kind of like that same line and go straight up and down? I don't think so, right? Because that top is a lot skinnier than that bottom. What about if I go the other way? Can I fold the triangle this way and create a line of symmetry? And that is correct. So number 5, the triangle only has 1 line of symmetry. Then for number 6, I'm going to do the same thing. Bring my sheet of paper over on top of my book, trace the rectangle. Now rectangle, if we actually go back to page 410, this rectangle is actually already done for us. How many lines of symmetry does a rectangle have? 2. So I can actually go back here right now and I'm going to draw my 2. But make sure it's in the middle. That one wasn't very in the middle, so I got to kind of change that. I'm going to change the colors for you guys so you can see that the green ones are the line of symmetry. So the rectangle has 2 lines of symmetry. Now number 7, we're going to have to look at the word math. So look at the letters in the word math. Which letters have 1 line of symmetry? Do any of these letters have more than 1 line of symmetry? And then it's asking us to explain. Okay, so first I am going to do number 7, and nice and big, I'm going to put the word math. M-A-T-H, and they're all capital letters, right? Okay, but I'm going to make that nice and big so we can see it. So instead of looking at shapes, now we're going to take a look at the letters to see if I can split any of these up to have lines of symmetry. Look at M. When I'm taking a look at M, I think I can see I can go right down the middle, right here. Ooh, I kind of have that off center with my computer, so let me fix it. Oops. Give me 1 second, guys, here. Remember I said I'll make it green so you can see it. Right, I can split that right down the middle for the M. Oh, I think I can do the exact same thing with the A. And probably the T. As well as the H, right? We're going up and down. Now, can I go horizontal at all with any of them? Let's take a look here. Can I go this way with the M? And I'm going to make that, let's make it a different color so it can kind of stand out. Can I go that way with the M? No. The A? Mm-mm. The T? But the H? Yeah, I can with the H. So I broke the word apart, but now I have to explain it. So for number 7, I have to now explain what I did. So the letters M, A, and T each have one line of symmetry, but then the second question asks, do any of these letters have more than one line? And we do. The letter H, oops, I gotta have a capital T, sorry. The letter H has 2 lines of symmetry. So that answers number 7. And that's only set A. Right now we're going to move on to set B. All right, 3rd grade. Now we're on to set B, and we're going to tell if the figures appear to be similar. We're going to write yes or no for 1 through 6. But I'm going to go back to page 412 and refresh my mind when it comes to similar figures. Figures that have the same shape but have the different sizes are called similar. So here these triangles look almost the same, right? But it got bigger. It went to a bigger triangle, went to a smaller triangle. Here is a square, smaller square to a bigger square. These 2 shapes look nothing alike, right? This has got a rectangle, this has a rectangle with a triangle on top. So those 2 are definitely not similar. But now these 2 look like they're both triangles, but are the same shape. The same figure of a triangle, but they're not the same shape because this one is kind of a tall and skinny triangle, where this is more of an even triangle with a 2 by 2 right here. So taking a look here at number 1, ooh, kind of looks like a rhombus, right? Or a lot of you guys like to say diamonds. Did it just get smaller? Did it change at all? I don't think it did. So number 1 is yes, they are similar. Number 2, well, that's pretty easy because number 2 just looks like it is a bigger circle versus a smaller circle. So 2 is yes. Number 3, well, they're both triangles, but look, this is an equilateral triangle because it has all equal sides and acute nonetheless, but then this one's actually a right triangle. So yeah, they're both triangles, but they have to be the same shape, and they're 2 completely different triangles. So number 3 is no. 4, I see a circle and then a wait a minute. Is that a circle? I think it looks more like an oval, like it's the circle, but it's stretched out sideways. So they're not the same shape. So number 4 is no. Number 5 looks like it is a square to a diamond. Yeah, to a diamond, but is the diamond or like the square just turned? Sure looks that way, huh? So don't get tricked by number 5. Number 5 is a yes. It just turned the shape. And then number 6, we have, well, they're both quadrilaterals. They're both 4-sided figures. The one on the right is a parallelogram. It's got 2 sets of parallel sides. But then number 6, that looks like a trapezoid because it only has 1 pair of parallel sides. So is a trapezoid the same as a parallelogram? No, it's not. So number 6 is no. Now number 7 is kind of an argument. So we're going to see if we can take a look. So Patty says that all squares are similar. Do you agree or disagree? Draw pictures to explain. Well, we're talking about squares. So squares, what I know, are all equal sides, 4 sides, and they all have right angles. She says they're always similar, meaning they have the same shape, but they may have a different size. So what I'm going to do, if I draw squares here, I actually put, number 7 here, and I'm going to first draw some squares. That's a square, that's a square, that's a square. They're the same shape, right? Squares all have to have right angles and they all have to have equal sides. But notice they're all different sizes. And that is a definition for similar, right? Figures that have the same shape but may have the different size. So is Patty, do you agree or disagree with Patty in that she says all squares are similar? Now we have to explain too. So what I'm going to put is that all squares are, let's bring that up there for you guys so you can see, are the same shape with being right angles, equal sides, even if they are different sizes. They are the same shape. And that is my answer for number 7 in set B. Now remember, this is a review for your chapter 20 open book test. Make sure you have set A and set B done. If you need to go back through, replay the video and pause and make sure you get the answer down.